Welcome to Lab 5 Part 2, where we will program the Gauss elimination method. Here we have the definition of the method. To start, we will import numpy as np, then we will define our function as Gauss elimination, with the inputs of A the matrix and B the solution vector. Then we also need n, the length of A in our calculations. We will also have to convert the matrix A into a numpy array where the numbers are floats. To do this, we will use dtype equal to numpy.float. We will do the same for our vector B equal to numpy.array B dtype equal to numpy.float. For step 1, we must form the combined matrix G, where G is an upper triangular matrix that looks as follows. To do this, we will set G equal to, first we must transpose the matrix A using A.T, which is numpy's transpose function, and then we must insert B into the last row. So we will use numpy.insert. We will insert into our transposed A into our last position n, and we will insert B, and then set axes equal to 0 to indicate a row insertion. And finally, we must transpose back using .t. Now we need to create our upper triangular matrix. To do so, we need to create pivots through subtraction. We need to do subtraction based on the pivot and the values below it in the same column. So we will need two for loops. The outer loop k will be the columns that we'll be subtracting along, and the inner loop I will be the rows we are subtracting from. So to do our nested loops, we will start with our outer loop for k in range n, and our inner loop will be for I in range k plus 1 to n. Here we will apply our equation from step 2, which states the following. Forward elimination, use the pivot elements GKK on the row K as pivot elements. Use the pivot elements to eliminate the components GIK with I from K plus 1 to n. This is done by iterating I from K plus 1 to n, and for each row I doing the operation row I equal to row I minus row K times GIK divided by GKK. So here we will write the equation for row I, which is G at index I is equal to G at index I minus G at index I, comma K divided by G at KK times by G at K. So this formula will set the value of G to 0 based on the pivot value. So now we have our upper triangular matrix. We can move on to step 3, which is backward substitution, which states that the element xi with I running backwards from n to 1 can be found using the following equation. Now we can step outside our nested loop, declare our matrix equal to numpy zeros of size n. Then we need our for loop, which runs backwards from n to 1. To do this, we will use for I in range starting from n minus 1 to negative 1 with an increment of negative 1, then colon. Inside this for loop, we will use the back substitution formula, which is x at I equal to, round brackets, g at I n minus. Now looking back at our formula, we have a summation, so we will use the sum function. We will take the sum of our list comprehension. From the formula, we can see the elements of the summation is GIL times XL. We can type G at I, L times by X at L. From the summation, we can see that our variable L is from I plus 1 to n. So for L in range I plus 1, n. And finally, we divide by the denominator of GII. Finally, we can return our matrix X using return, and we can return it as a numpy v stack and then X. Now go ahead and run our function, and now we will test our function with A equal to the identity matrix and B will be equal to a vector of 1, 2, 3. Then print, then call our Gauss elimination function and pass in A and B. As expected, we get 1, 2, and 3. So this code will do the naive Gauss elimination method without switching rows, which means that we cannot use it for any zero pivots. In order to error check for zero pivots, we can use if and else statements. In order to display an error message, we will make use of a flag. Before our for loops, we would declare a flag here, and inside our outer for loop, we would change the flag if a zero pivot is found. Then we would need a second if statement just outside our nested loop that would check to see if the flag has been changed. If yes, return the error message and exit the function. Otherwise, we can continue with the rest of the code.